Hello everyone. In this session, let us look into a numerical problem from the concept of direct step method. Let me remind you, direct step method is one of the methods widely used in the computation of gradually varied flow profiles. This is how the problem statement goes. A trapezoidal channel having a bottom slope of 0.001 is carrying a flow of 30 meter cube per second. The bottom width is 10 meter. The side slopes are 2 horizontal to 1 vertical. At the downstream end, a control structure rises the water to a depth of 5 meter. Determine the water surface profile at the upstream of control structure. Manning's n is given, and that is about 0.013, and the elevation of the channel bottom at the downstream end is 0. How do we visualize this problem statement? Very simple. The cross-sectional details related to the trapezoidal section being the width 10 meter. The side slopes are denoted in terms of a ratio 2 horizontal to 1 vertical. So what we are supposed to calculate is this. Let us calculate the upstream profile, and we also are supposed to calculate the length of the backwater or the curve which is supposed to be obtained. First, we calculate the geometric parameters such as area, wetted perimeter, and then hydraulic radius for the given cross section. How do we calculate area? According to the formula b plus ny into y, area is 10 plus 2y into y. Wetted perimeter is b plus y into square root of 1 plus n square. P equals to 4.46y plus 10. The top width 10 plus 4y. Now we calculate r, the hydraulic radius, with the help of area and the wetted perimeter. We substitute the values for area and wetted perimeter here. The q value, the discharge, equals to a into 1 by n r to the power 2 by 3 s to the power half. The classical Manning's equation is utilized to calculate initially the value of y naught and later q at the given cross sections y equals to certain values. Now we use this delta x as the step, the dimension of a step, to calculate the initially delta x values, and later the summation of all delta x values, they lead to the length delta x equals to delta E divided by S naught minus SF average, where SF average is calculated as the average of SF1 and SF2. Delta E is the difference in the specific energies, even difference E2. Now first, initially we have to calculate Y0 and YC to observe the profile of GVF. We have to take certain decisions related to the slope and later the profile also. So to calculate that, we need to determine YC. How do we calculate YC? This belongs to a trapezoidal section. We go with q square t by ga cube equals to 1. We substitute the values for q square, g, and the area and the t in terms of y. We run a trial and error method, and that's how we calculate YC. YC is 0.91. Remind you, YC is the depth at a critical section. Now we also calculate Y0, which is a normal depth. We use Manning's equation q equals to a into 1 by n r to the power 2 by 3 s to the power half to calculate that. And again we run one more trial and error method, and we end up with a value of Y0, which is equals to 1.1 meter. Now the decision is fairly simple. Y is known to us, YC is known to us, Y0 is also known to us. With the help of all these things, what we have here is Y0 being greater than YC. So the profile, the slope is m, the mild slope. The profile is m1 just because y is greater than Y0 and Y0 is greater than YC. This is how we arrive at a conclusion saying that the profile is M1. Okay, now we have to investigate some more things related to M1, at least the profile, the backward length related to M1. So to do that, we draw a table which consists of Y, area, velocity v square by 2g, the specific energy, the differences in the specific energy, and then r to the power 4 by 3, SF average, S naught minus SF average, delta x, and accumulative narrations of delta x are tabulated under the length. And lengths are in terms of meters here. Say a y equals to 5 meters, the depth of flow is 5 meters. Now, based on that, area would be 100 meters square. The discharge divided by area would be the velocity, v square by 2g is this. Energy is calculated as v square by 2g plus y 5.0046. Delta E has no values for the first trial. R is calculated with the prescribed equation, which consists of Q and N. Now we raise up R 4 by 3 to that, and SF is calculated, which is into 10 raised to something. SF average is calculated, S naught minus SF similarly. For the second trial, we get the values of delta E, which is the difference between 5.0046, 4.0089, and SF average is the average of these two values. S naught minus SF average is S naught, which is given in a problem statement, and we take a difference of the values between S naught and SF average here. Finally, when we have y equals to 1 meter, which is assumed, we end up with the value of length equals to 5877, which is approximately 5 kilometers. Now to summarize, this is what a given problem supposed to be. The first step is around kilometer, around 2 kilometer base for the second step, and for the third step, which is around 2.796 kilometers. So altogether it is about 5.877 meters kilometers. So this is how we solve a problem in the direct step method. Now just to remind you, the slope was mild and the profile was M1. Thank you.